All right, distance between 2 points. That's the distance formula. x2 minus x1 squared plus y. This is like a summary. Okay. Midpoint is capital M for midpoint. Average of the x over average and average of the y. And the gradient will be small m, y2 minus y1 over x2 minus x1. And the good thing is that the first two are on the formula sheet. That's on the formula sheet, that's on the reference sheet. I think that's the only two you are given. Oh, there's a third one, which is the perpendicular distance. That's given on the formula sheet. Everything else you need to know, right? So that's on the reference sheet. So the midpoint is not on the reference sheet, so make sure you memorize it. It's also the easiest one, you're right. All right, let's continue. How do I prove two lines are parallel? Yep, M1 equal to M2. Proving two lines are perpendicular. M1 times M2 is -1. Angle of inclinations, the angle the line makes with the x-axis, tan theta equal M. Right, I think you know a lot of this. Equation of a line given the gradient and the y-intercept, gradient intercept form. Yep. And then next one, equation of a line given a point and the gradient, y minus y1, is also important. I think this one's on the formula sheet. I'm going to check it right now. Yeah, that's the only 4 on the formula sheet. On the formula sheet, you're only given 4 formulas. Let me just get a bit smaller. So the one that's on the formula sheet are this and this. Everything else are not on the formula sheet. This one, this one, this one, this one. So you need to know this. Say again. I don't know. You have to ring them. Okay, good. Next one, area of the parallelogram. Hope you remember. Because in this topic, they ask you to find the area of shape. So if I draw a parallelogram, the area of it is the base times the perpendicular height, PH. Right? Perpendicular height. And the area of rhombus is the length of the two diagonal multiplied together. So you get A equal half of xy. Right, that will be used in questions. And also remember with the HSC question where they ask you to find the area of the trapezium. Let's revise this. So you got height, A and B. Half H, A plus B. Is this stuff on the reference sheet? No. Reference sheet doesn't have this stuff. So you need to memorize these formulas. But these are the things that you've been learning since year 8 or even year 7. I remember going through this in year 7. So that's something you need to remember. Alright, how do I show points are collinear? What does collinear means? Lies on the same line. And to do that, we'll just have to show the gradients are equal. Right? And to show a point lies on the line, you just have to substitute that point, so x1, y1, into the equation of the line. And show that it works. And show lines are concurrent means that one point passes through all three lines pass through the same point. Passes through same point. Okay, good. So that's concurrent, collinear, etc. And then you need to know the equation of a vertical line. vertical line looks like this, x equal to a number, horizontal line, y equal to a number. And then prove a line, bisect an interval. Bisect means cut it into half. Right? So if you bisect it, means that it passes through the midpoint. Passes through midpoint. Okay, done. Equation of the line. Yeah, shorthand for equation. Let's write it here. All right, cool. So these are the formulas that we'll be using, and then we'll go to the next page. Actually, we do have to do 4 pages, not 3. I miscalculated. All right, 4 pages. So we've got 3 more pages to go. All right, all done. All right, let's go through this. Now, remember the test that we learned from quadrilateral in chapter 4, geometry? Okay, how to prove a quadrilateral is a parallelogram. Remember the 4 tests, 5 tests? What are the tests? Let's write them down. Opposite sides, parallel. Yep. Opposite sides, equal. Actually, I want to leave some space there because I want to relate that to this topic. So if you can leave a line, opposite sides, equal. And then there's another opposite angle equal. Opposite angles equal. And what else are there? Opposite sides equal, parallel, opposite, and then the 4th one is diagonals bisect each other. And the last one is a combination of the first 2, 1 pair of sides, both equal, yep, equal and parallel. So you have to see me in the afternoon. I'll be in the library. For what test? When are you going to bring it back?
Yeah, I will.
When?
Like 2 hours?
2 hours?
An hour maybe?
What time? 2 hours. I'll be at lunch. We'll be at the library?
Yeah, I'll be at the library.
Alright. Actually, 12. If you 12, come back here because I'll be in class. Yeah. Okay. Alright. Okay, let's go through. Okay, these are the 5 tests. Hopefully you still remember. If not, they are the 5 tests. Now, why do I leave space? How does it relate to this topic? How do I prove sides are parallel? What sort of things we use? What's the parallel formula? Yes, gradients equal. So let's draw a parallelogram here. A, B, C, D, right? So you just have to prove gradient of AB equal to gradient of DC, and gradient of AD equal to gradient of BC. So you have to calculate 4 gradients and make sure they're all equal. Make sure you find 2 pairs are equal. Okay, how about the other one? Opposite sides are equal. You prove the length of distance AB equal to distance DC, distance AD equal to distance BC, right? But which one will be faster, the parallel or the sides in terms of calculation? Yeah, because the gradients are much easier to calculate than distance. Agree? So this one I will try to avoid if possible because it's longer to do in this topic, right? Because the distance formula is complicated. Whereas this one is quicker. How about opposite angles equal? Have we learned how to find angles between 2 lines? That's harder, isn't it? So again, avoid. It's hard to do angles in number plane. I mean, when I say avoid, it means avoid in this topic, but not to avoid it in geometry. But in number plane, avoid it because in number plane, it's very hard to calculate angles. Okay, how about this one? Diagonals bisect each other. What do we do? If they bisect each other, that means the midpoint are the same. That will be my favorite one. Put a star there. Because all you have to do is find the midpoint of AC and show that equal to midpoint of DB. And how many calculations do you do? You just have to do two calculations. Now compare with the gradient one, that's pretty quick, but not as quick as this. See, that's just one calculation for the midpoint, second calculation for midpoint. This one you have to do 4 calculations. Gradient AB, gradient DC, gradient AD, gradient BC. Does that make sense? This is the fastest. So I recommend you to do that whenever you try to prove parallel, whenever you want to prove it's a parallelogram. Okay? Alright, so this one I will actually even highlight because this is a very easy one to prove. Okay, any question? And the last one you just know. The last one you just have to prove that the one pair of sides both equal and parallel. So all you have to do is to prove that distance AB equal to distance DC and gradient AB equal to gradient DC. So you can do it that way. But again, that's not as fast as this. This is the fastest to prove it's a parallelogram. All right, jot this down because you will be using that in some questions. Yeah. Okay, continue. All right, any questions? Pretty easy. All right, let's look at rhombus. How do I prove something is a rhombus? What's the test for rhombus? Anyone could tell me? All sides equal. Let's write it down. All sides equal. Any other tests? So that in that way, we just have to prove all AD equal to distance of DC equal to distance of DC equal to distance of AB. Again, as you can see, finding distance is very long. So that may not be the best test, even though that's the easiest one to remember. All sides are equal, but it takes a long time to calculate for distance. Okay? What's another test? Diagonals bisect each other at 90 degrees. So it's a bit like parallelogram, except that you have the extra 90 degrees. So they're perpendicular to each other. So if I draw a picture, it will look like this. Not well drawn. Okay, so you just have to prove the diagonal are bisect at 90 degrees. So what you have to do is to do 2 things. One is to show the midpoint, if that's ABCD. So show the midpoint are equal, midpoint of AC equal to the midpoint of BD, right? And the second thing you do is perpendicular. Gradient of AC multiplied gradient of BD must be equal to -1. So that's the fastest. Again, I will highlight it. Okay, that's the best one. Okay, I'll put it there. Of course, not wrong to use the first test, just very long. This is much faster. Midpoint's quick, gradient's quick, but distance is slow. Okay, any other ones? Okay, let's move on. Oh yeah, angles are bad, so we'll try to avoid it. All right, okay. All right. So how do I prove it's a rectangle? Let's cut out all the not necessary things. So we just have to prove that 2 things. For a rectangle, all you have to prove the diagonals bisect. That will prove it's a parallelogram, and also prove that the 2 lines are equal to each other. All right. So diagonals bisect each other, and diagonals are equal. Okay, that's the best one. So again, in that case, if I got ABCD again, you have to prove that midpoint of AC equal to midpoint of DB. And also, instead of gradient, use the distance. distance AC equal to distance dB. Again, that will be the fastest way. So a little bit similar to the rhombus, gradient one, they both use midpoint are equal, but the rhombus one, you have to show that perpendicular. The rectangle one is to show the two diagonals are equal to each other. Yep. Move on. How to prove it's a square? Very easy. Now, to prove a square, there's many ways, but again, I will emphasize on the diagonal approach. It's very easy. So you just have to combine rhombus and rectangle. So if you combine them, you have to show the diagonals bisect. Right? That means prove it's bisect. And then you also have to prove that the distance, they are perpendicular. And then you have to prove that distance AC equal to distance dB. So that's the easiest way. All right, now we've got all of these tests for all special quadrilateral. All right, thank you very much. Now we can do some exam type question. We've got a couple to go through, a few to go through. Oh. I will go through slowly. Make sure you pay attention because you started talking. Every time I finish, you started. Has got one midpoint equal. So rhombus goes more specific, have one extra condition, and the rectangle have the other one, the distance equal. The square has everything, right? Right, good. Okay, what else are there? We're now going to go to example 38. Hopefully you're ready. All right, next page. All ready? All right, still writing. Okay, let's move on. Next page. So it's still recording. That's good. No problem. Okay. All right. Example 38. Given the points are these, notice that they are labeled on the diagram. Find the gradient of AB. That's easy enough, right? Let's go gradient of AB. Every time I find gradient AB, I always put AB in the gradient. So I know I'm finding the gradient of AB, not gradient of any lines. So we'll do. All right, good. Let's continue. 4 minus negative 8 over negative 7 minus 5. What do you get? 12 over negative 12. Get negative 1. Okay, how about distance? Now, when you find distance, instead of write DAB, I just write AB. Because AB stands for the side. So if you just write AB, it means the distance. Just easier. So we'll just go like this. 4 minus negative 8 square plus negative 7 minus 5 square. What do you get? Use your calculator. You get 12 root 2. After simplifying. How do I know it's 12 root 2 so quickly? Because that's 144 plus 144, which is equal to 2 lots of 144. But when you square root 144 is 12. That's how I do it so quickly. So it's very easy without a calculator. Oops. All right, so we'll go back here. I'll write it again. All right, thank you. I got it? Okay, next one, midpoint. How do you find midpoint? These are all revision. All right, midpoint AB, capital M. All right, you do the average. So average of the X, which is negative 7 plus 5. Average of the Y, which is 4 plus negative 8, equal. So we found everything there. What do you get? You get negative 2, right? You with negative 1, negative 4, which is negative 2. Done. Right, we found all three. The gradient is negative 1, the distance is 12 root 2, the midpoint is negative 1, negative 2. Right, let's find the equation. What's the equation of AB? How do I find the equation? So you can do so many things with 2 points. You can find the distance, you can find the midpoint, find the gradient, you can also find the equation. And then you can find the angle. You can do so many things with 2 points. Very cool, isn't it? Okay, let's do it. Find the equation of AB. What method do we use? Both are fine. Okay, depending if they're fractions. There's no fraction, I'll just put in y equal mx plus b. Okay, let's put in distance, gradient intercept form. What do we do? Actually, sometimes better with general form, because later on when you find the distance from a point, it's easier with the general form. Okay, let's put in general form. So, do we know the gradient of AB? -1. What's the corner of A? You just use the formula y minus y1 equal to mx minus x1, which is also on the formula sheet. You just need to know how to use it. I'll make it a bit bigger. It doesn't matter. You get the same equation. You could try that later. Okay, or you can just trust me. You trust me, okay. Alright, so what do you get? You get y plus a equal to -x plus 5. I'm going to put in y-intercept form because it's just easier to read. What do you get? You get -3. Equation found. And then when we need it, we'll put in general form when we need it. Alright, now we have to find the angle the line makes with the x-axis. Think about what to do. Yep, so the line makes with the x-axis this angle, and that angle can be found using the formula tan theta is m. So tan theta equal to -1 because the gradient is -1. It's always the angle with the x-axis, the positive direction. So if the line was here, you got this angle. If the line was like that, you got this angle. You always start from the x-axis. Does that make sense? Yeah, you always start turning from here until you reach the line, right? You always start from the x, the positive direction of x. Okay, not below it, no. How come not below it? You could, but what's the meaning? I mean, I could find this angle, or I could even find this angle. You can find any angle, but it just makes things complicated. Yeah, so it just makes theta. Okay, good. Let's go through. How do I solve this? Remember, it's negative in the second quadrant. How do you find the second quadrant? 180 minus the related angle. And when you do tan inverse of 1, that's 45 degrees, which is 135. Okay? Right, that's a good question. Went through so much. That's good. I think that's a rhombus. Area of the rhombus, parallelogram, perpendicular. Very nice. Okay, and then okay, that's trigonometry. So you try to find the angle. So it's in the second quadrant. So in the second quadrant, what do? You find a related angle, which is 45, and you find this angle, which is 135. Yeah. All stations to central. Remember, second quadrant tan is negative. And find a related angle by tan inverse of the positive. Yeah. So tan inverse, and then subtract that from 180, you get 135. Yeah. Okay, let's continue. What else you have to find out? The line AB intersects the x-axis at D. How do you find D? No, D is where the line crosses the x-axis. That's the x-intercept. How do you find x-intercept? Y equal to 0. Let's do that. Y equal to 0. And remember, the equation of the line is -x minus 3. How do you put 0? What's x equal to? -3. So what's the corner of D? You still have to answer the question. What's D equal to? Yeah. So make sure you answer the question. All right, good. So we've got D. Close. And then we'll have to do G, distance of C from AB, and then find the area of the triangle. That's a very good question. Get to use everything we've learned, loads of things in this topic. Okay. I forgot whether I wrote it or I used some other sources. Yep. Okay. G. All right. Okay. Let's look at. Yep. 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 That's good. Yep. Okay. Now let's. All right. We're going to find the distance of C to AB. Whenever we find the distance, it's the perpendicular distance. Okay. Let's find the perpendicular distance from C to AB. That's why you have to put it in general form. X plus y plus 3 is 0. That's in. I use a magic pen. So it's this line. Right? Actually, I used the wrong pen. Okay, it's this one. The magic pen. Yeah, this one. And then it will disappear. Doesn't disappear. Oh, it does. Okay, good. All right, excellent. Okay, now let's do that now. Now I have to get a magic pen. All right, good. Okay, let's do this. Perpendicular distance is absolute value 3 plus 6 plus 3 over the absolute square root of 1 square plus 1 square. Okay, what do you get? 12 over root 2, right? That's the distance of C from the line. The one comes from here. Got it? Yep, that's the formula. Remember, this is the exercise you did last lesson. All right, let's move on. So,
we asked you to explain it, and you were like, no, I'll only explain it. Okay.
All right, let's continue. How do you find the area of the triangle ABC? We got the perpendicular distance. So what was the perpendicular distance? Distance 12 over root 2. What's the length of AB? The length is 12 root 2. So what's the formula for the area of triangle? 5BH. So this one is like your H. This one is like the B. The distance we found earlier, B. Yep. No, you don't need to. You see why in a minute. The base is 12 root 2. The perpendicular distance, 12 over root 2. See what happened? They get cancelled. Right? I mean, should you rationalize? Yeah, you can, but I don't think it's necessary. What do you get? 6 times 12, 72 square units. Done. Yep. Yep. This one. Oh, you want the triangle? Yep. Okay. Finished. Done. Let's move on. Next page. Last page of this booklet before you get your new booklet. What's the quote? Cool. I may put it on. Okay. All right. Let's move on. Okay. Consider the points. Prove that they are perpendicular. How do I prove things are perpendicular? What -1? Well done. Okay. What's O? O is the origin. Why don't you do it now? Go. Find the gradient of the OB. Find the gradient of AB. See what happens. Go. All right. Something of B minus, yeah. So let's try to do that. So you go 0 minus 0 over 15 minus 0. Got the idea? Oh, oops. That's OB. All right. So what's OB? Okay. 6 minus 0, 3 minus 0, 2. Gradient's 2. Find the gradient AB. Have a try. Okay, next one. What do you get? You get 0 minus 0 over 15 minus 0. You get 0. Oh. Oh, AB. Oh, so oops, sorry, not OA. 6 minus 0. Oh, yeah, sorry. 0, 3 minus 15. What do you get? Yep. So you times them together. You get 2 times the negative reciprocal, you get -1. And you write conclusion. Alright, get the idea? Done. How do you find the area of the triangle? Let's draw a brief sketch. Now, O is here, A is here, B is somewhere there. That's 3, 6. That's the triangle. Who can suggest what to do? That's a right angle, by the way. What can we do to find the area of the triangle? Which one's the perpendicular height? Yeah, this one, right? Is that the one you're talking about? Yeah. That will be the easiest one. Because sometimes you may think, oh, it's a right angle triangle. Let's find the distance OB, find the distance BA, and times them. That will take a long time. Easier if you just go this. This is 15, right? What's this height? 6. Can you see how quick it is? Instead of finding distance. So the area is half times base times 6. And what did you say? Oh, amazing. All right, 45 square units. Right, so when we find area of the triangle, try to find the perpendicular distance because this is easy, right? You can just read it off from the number. If you try to find the distance, that will take a long time. So look out for these things. Look out for the perpendicular height because it's easier to find. What else are there? We're going to finish soon. Good. Okay. Prove the figure is a parallelogram. Remember the test for parallelogram? What was the test again? Who can tell me what the test is? And how do I prove diagonal bisect? Midpoints are equal. But which midpoint do we find? The diagonal, right? So how do I know that diagonal? A and B must be next to each other, right? So AC must be opposite to each other. So you find midpoint of AC without even drawing. So you go A plus B on 2, C plus 0 on 2, which is equal to, you just leave it as A plus B, this one C over 2, right? Yeah, but that's going to do 4 gradients, 4 calculations. Have a look at the midpoint. I only have to do 2 calculations. Does that make sense? It's quicker. That's all. I mean, you can do it that way if you want to, but you don't need to. I mean, see, midpoint's so quick. It's just so quick. It's, yeah. Right? It's very easy. And you do get the same thing, isn't it? Right? So you can say, therefore, midpoint of AC equal to midpoint of BD. Therefore, you say ABCD is a parallelogram. CD is a parallelogram. And make sure you write down the test. Is a parallelogram. Diagonals bisect each other. Right, one more. All done? Now, how do I prove something is a rhombus? Who can remind me? Bisect each other at 90 degrees. So you have to find 2 things as well. Find midpoint. Let's do that first. So you go 1 plus 3 on 2, negative 1 plus 6 on 2. That equals to 2, 2.5. Midpoint of BD equal to negative 4 plus negative 6. 4 minus 3 on 2. I made a mistake. No, I didn't. Why didn't it work? No, it works. Oh, hang on. Well, it doesn't work. They don't bisect. No, I must be... let me think. No, they do. So maybe I labeled the vertex wrong. So it's not 8. So sometimes I think they should go in order. Let's try. 1, negative 1 is here. 1 across here, and then B is -4, 4. B, yeah, C there, and then C is 3, 6. 3, 6 is there. Yeah, I think it's actually ACBD. So A and B are opposite to each other. That's a poorly written question. I think I copied it from somewhere, so it's not my fault. Okay. All right, okay. All right, let's do this. So I think A and B are opposite to each other. All right, but you can't tell until you plot the points. So sorry about that. Okay, I should have checked it before. But in future edition, I'm going to put that as C. All right, yeah, future edition. Until they stop here. Hang on. That will be, I change that to C, change that to B. That will fix the problem. Okay, but anyway, that's for future. So we're going to do, may not be because that, I don't think this is in the new syllabus. Okay, so we go, am I recording? That's good. All right, good. So let's find midpoint of AB, which is equal to 1 plus -4 on 2, -1 plus 4 on 2, equal to, what do you get? -3 on 2, which is -1.5, and the other one is 1.5. All right, and then you do CD. All right, they're the same. So we just prove that AB and CD are actually right. Midpoint of AB equals to midpoint of CD. Therefore, AB and CD bisect each other. So every time you calculate something, write a conclusion so that people know what you're doing, or they could see what you are doing. And then you have to prove that perpendicular, so you find the gradient of AB, which is equal to -3. Oh no, gradient of AB is 4 minus -1 over -4 minus 1. You get 5, -1. Gradient of CD is -3 minus 6 over -6 minus 3, which is 1. So therefore, if you multiply them together, you get -1. Therefore, you say AB is perpendicular to CD, and that perpendicular, therefore you can say that ABCD is a rhombus. Okay, good. Done? Done. Good. Oh, that was quick. Okay. All right. Good. Last part. How do you find the area of the rhombus? What's the formula? Yeah, so X and Y. Y is half XY because the horizontal line looks like the X-axis, vertical line looks like the Y-axis. So half XY. So basically, you just have to find the length of AB, which is opposite to each other, length of CD, which you have to use the distance formula. Let's do that. AB equal. AB is, when we did the gradient, sort of gives you that's equal to 5 squared plus 5 squared, 5 root 2. I skip the working, I leave it to you. CD is 9 squared plus 9 squared, which is 9 root 2. Then the area will be half times 5 root 2 times 9 root 2. The root 2 with 2 we can times together, you get 45 square units. Oh, I managed to fit all on this small space. All right. And of course, you want that inspirational quote is success. What do they call it? Genius. Or whatever you call it, genius or success is 1% inspiration, 99% perspiration. From the famous person who invented the light bulb, Thomas Edison, in 1902. That's from there. Okay, done. All right.